Okay, this is chapter 6, Analytic Geometry. This is the first part of chapter 6, circles and parabolas. And these we're also going to just do circles today. The other two topics are ellipses and hyperbolas. And that's only 4 things we're going to do in this chapter, but that will probably be quite enough. Okay, so circles and parabolas, these are, and ellipses and hyperbolas are all conic sections, right? If you cut a cone in a certain way, that becomes the shape we're talking about. If you cut the circle, go straight across the cone, that's a circle. If you go at an angle across the cone, that's the parabola. If you go from an angle through the base, you get a parabola. If you go straight down from the base through the side of the cone, then you get a hyperbola. Okay, we're going to talk about the circle today, and the mathematical definition of a circle is a set of points in a plane that are equidistant from a fixed point. And that distance is called the radius of the circle, and the fixed point is called the center. So you have a center of a circle, and all the points that are the same distance from that point, they make the edge of the circle. And they are how far away from the center? Well, they're the radius. However big the radius is, that's how far it is. So you can draw a circle if you hold the take a piece of string and tie it to the end of a pencil. If you draw that around, you can draw a circle, or if you use a compass, put the point of that and make the pencil go around, you can draw a circle. So the circle is just the same, all the points that are the same distance from the center. And to find that radius, this equation here comes from Pythagorean theorem, h squared, and h and k, we use those at random, are where the center of the circle is. So if the center is at the origin, this just becomes x squared plus y squared if h and k are 0. But if h and k are offset, if our circle is up one, and over somewhere, then we kind of have to offset this to figure out what the radius is. Okay, so, and then that yields, we square everything and we get r squared equals x minus h squared plus y minus k squared. Okay, so that's the equation of the circle we're going to deal with today. Okay, so if the first example is find the center radius form of the equation of the circle with a radius of 6 and the center is here. Graph the circle and give the domain and range of the relation. Okay, so to do that, we just had that circle equation on the last page here. This r squared equals x minus h and y minus k. So the h and the k are the center of the circle. H goes with the x and k goes with the y. Alphabetical order, h, I, j, k. X goes before y. The h and the k go alphabetically in order. Okay, so to do that, we're just going to substitute into that equation. And it looks something like this then. We get r squared, 6 squared, and then we have the minus 3 here for the x value. Minus 3 becomes a plus 3, and then the positive 4 still becomes minus 4. Now why they do it like that, if you graph where this center is here at negative 3, positive 4. Okay, so the way I think about this is that this is, to get back to this equation, to get the radius, if I put this back at the origin here, I'd have to go back 3. I'd have to add 3 and subtract 4. I'd have to add 3 and subtract 4 to get from this point back to the origin. And then my equation would just become r equals x squared plus y squared. So this is kind of the offset we do to make it have a radius of 6 around this point. And the domain, we would just add, since the radius is 6, we would add 6 to, we'd subtract 6 from the x number, so minus 3 minus 6, negative 9. Add 6 to the x number, so minus 3 plus 3. That's our domain. The range, we add and subtract 6 from 4 to go up to 10 and down to negative 2. So that's our domain range in the green and the domain in the red. Okay, so if you want to graph this on your calculator, the calculator cannot do, x plus y squared, or at least the ones that we use can't. Some of the fancier ones can. But most of the time you have to get, okay, you have to get y equals something to graph it. So you solve for y, and you get plus or minus the square root of 9 minus x squared. So you put that in the calculator, but you have to put it in twice. You have to put in the positive value and the negative value to get the going up and the going around and down. And it'll look like this, and to make it look like a circle, not an ellipse, use, it's called the square thing. When you hit the zoom key and you look down there, we usually use number 6 for standard size, but there's one that says square window there too. So use the square window, and for most of them it'll look like a circle when you do that. Okay, so a lot of the problems you have for homework, one of the tougher ones, are example like this. They give you an equation like this, and they want you to find the center and the radius of the circle with this equation. So the goal is to get it to get this equation to look like this, because this is the center is at h and k, and the radius is r squared. To do that, we have to complete the square of both x and y. Okay, so to do that, first off, we need to isolate the x and y variables in this equation. Okay, so I'm going to try my little pen thing here. And to do that, I'm going to put x squared minus 6x. And to complete the square, I'm going to leave something here to complete the square. That wasn't too good. Okay, plus, and then I'm going to do the same thing with the y variables, y squared plus 10y plus something to complete the square. Now I'm going to just go ahead and put this 25 up here, this 25 right here. I'm going to move this over to the other side. I'm going to get that off to the other side of my equation. So I just have the x's and y's on one side. So I put the minus 25 over there. Okay, so far so good. So I bet this is a pretty simple one, so I bet you can even see how we're going to complete this square already without doing anything. So the idea is that you take this b variable here, divided by 2 and square it. So 6 divided by 2 is 3. 3 squared is going to be 9. Same thing with the 10 here. 10 divided by 2 is 5. Squared is 25. Okay. But the thing is, you have to, whatever you do on this side, you have to do to the other side. So if I added 25 here, I have to add 25 here. So you can see that this one is a fairly easy example that these are going to cancel out. I get 0 here now. Okay, but I kind of forgot to add this 9 over here. So I need to add this 9 on the other side too. Okay, so I get a 9 there. So you can see what this is going to equal. I imagine you can, because you guys are smart pre-calculus students, by God. Okay, so this is going to be x, and it's got the minus here, so it's going to be minus 3 squared, right? That's why we complete the square, so we can get it to look like this, right? We want it to be a perfect square. So we physically force it to look like this, and so by completing the square. And y, and it's going to be plus 5 squared equals 9. So that gives me a center at, the center point is going to be positive 3, right? It's the opposite of whatever the sign is here. And then the y value, since that was plus 5, is going to be negative 5. And the radius is going to equal 3, because this 9 is the radius squared. Okay, so here it is. Oops. So well, I guess I left room to do it over here, but I just did it on that side instead. So that's the original equation. This is what it looks like, all neat and tidy. So this is except that they screwed up here at the end. I just noticed that this is, I don't know how they went from +2, +5 to +2. It should be what I said. It should be -5 here, not -2. So I don't know how that happened. just like I said on the other page. So you completed the square. All this equals 9. This is correct here. This is not correct here. When it's the plus 2, it should be the plus 5. Okay, so one more example here. Have this one, similar kind of thing. So here's the steps. Separate the x and y variables. Complete the square for both the x and the y. You kind of do those separately. Make sure you add whatever you use to complete the square to the other side. And um, then you want it, does it fit this? Sometimes it will, sometimes it won't. So most of the ones we're going to do here is going to fit. Okay, so what do we need to do? We need to put in, separate our x and y variables. So, oops, I'm going to change my pen here. Okay, so my x and y variables, I'm going to separate those out. X squared plus 8x. Now I'm going to plus something to complete the square, plus my y variables, y squared minus 6y plus something to complete the square. And I'm just going to go ahead and put this 16. Right, that's 16. I'm going to put it on the other side here. So I'm going to subtract 16 and get negative 16. Okay, so far so good. Pretty easy example here. You guys probably got this down without doing any more. Okay, so then half of 8 is 4. So that's 16. So I need to add 16 on this side. So that's going to cancel that out, right? So it's just going to be 0 now. Then to complete the square here, it's kind of a sloppy 6, but 6 divided by 2 is 3. 3 squared is 9. So plus 9. Okay, so what it's going to look like now, when I get everything on this one, the way why we complete the square is so we get it to look like this. X plus 4 squared. That should be a 4 squared plus y minus 3 squared equals, in this case, it's going to equal 9. So my center is at, my center point is, that's going to be a negative 4 and a plus 3. And the radius is going to equal 3. Okay, so I hope that helps. We're going to have problems tonight on the out of the book, and I hope that helps you with your circle stuff.